Hi, everyone. Today we're going to review area for a big chapter test on Monday. So this video will be in two parts. So the first part, I think, is 1 through 12 questions from your review packet. So get that out and we'll start going over some of the problems. All right. First question is, the circle has radius 5 and a minor sector degree of 120. Find the arc length and the area. So first thing let's do is let's make a circle. Radius 5, minor sector degree of 120. So try to draw 120 degree angle in there. And so actually the area that we're going to be looking for is in here, whereas the arc length will be from here to here. Okay, so in order to find the arc length, if you recall our formula, which is arc degree over 360 times 2 pi r. So that's going to be 120 degrees over 360 times 2 times pi times my radius, which is 5. These will cancel. 1, 3, what's that, 10? What's that, 3? So that's going to be 10 pi divided by 3. And so that's our arc length. Our arc degree, or our area of that sector, so we'll say area of the sector, is going to equal arc degree over 360 times pi r squared, because we're finding the area of the whole circle, but then we're taking just a fraction of it, and that's the 120 degrees. So we'd say 120 degrees over 360 times pi times r is 5, squared. So again, this cancels. This is going to become 1 over 3. Looks like we're going to have 25 pi over 3, and this is units squared. Okay, that's our area. Number 2, find the area of the non-shaded region. So for this problem right here, for the non-shaded region, you're going to find, let's see here, we're going to find arc degree area of non-shaded. Area of non-shaded. This one's a little bit tricky. It's because we have to find the area of the whole circle, but then we need to actually take away this triangle inside here in order to get to this top part right there. So we're going to find, we're going to find a couple of things. So our plan of action is to find the area of the circle minus the triangle, which is 1/2 base times height. And then we have to take away the shaded region also. And so that's going to be area of that sector. Okay, so we have pi r squared minus 1/2 base times height. Well, that's a triangle. Remember, the base and height have to be perpendicular, so that's going to be a little tricky there. Minus the area of the sector, which in this case is arc degree over 360 times pi r squared. Okay, so we're going to say area of the circle is going to be, what's that, radius, so 6 squared pi minus 1/2 base times, now base times height. So if you look at the side here, you're going to see a triangle, but know that even though that's 120 from here to here, that becomes 60, and then that's 30. And so what happens is across from, this becomes 6. So across from the 90 is basically equal to 2a. So a is equal to 3, and a is across from my 30 degree angle. And then across from my 60 is a root 3. And so you can use the Pythagorean theorem to find that if you don't want to use a shortcut. So your base times your height. Now, this is where several people will make a little mistake here, because we want the entire base. Okay, so if that's 3 root 3, that's also 3 root 3. So that makes my base 6 root 3, and then times my height, which is just 3. And I'm going to subtract my arc degree over 360, but keep in mind, I have to take away this shaded region because I want the non-shaded region. So in order to take this away, 360 minus 120 is 240 degrees. So this is actually 240, this area, this space right here. So that's going to be 240 degrees over 360 times pi r squared. What's r? R is 6. Okay, so now we have 36 pi minus, let's see, 2 goes into 6 3 times. 3 times 3 is what, 9? So we have 9 root 3 minus, and then 240 divided by, oh boy, let's see here. This becomes here. Actually, 6 times 6 is 36. So I'm going to cancel that with that. And I'm going to get 24 times pi, which is 24 pi. 36 minus 24 is 12 pi minus 9 root 3. Keep in mind, separate. You can't add those two together. So that's units squared. So that was kind of a tricky problem, but doable. So the diagonal of a square, let's see, is 2 root 6 square. So let's draw a square. Okay, so the diagonal right there is 2 root 6. Find the area of a square. So the area of a square is equal to the side length squared. So we need a side length. So we know that, we know a little shortcut. If this is x, that's x. That's x root 2. If you forget that, you can always do it and go x squared plus, use Pythagorean theorem, is equal to 2 root 6 squared. So that's 2x squared equals 2 root 6 times 2 root 6, which becomes 4 times 6, which is 24, equals x squared, 2x squared. Divide by 24, I have x squared equals 12. Let's see. And then we're going to square root both sides. And we get x equals the square root of 4 times the square root of 3. Square root of 4 is 2. So this becomes 2 root 3. So that's the length of one of my sides right here. Now, if you remember the shortcut, though, let's just talk about that for a second. 2 root 6, set that equal to x root 2. Because remember, x root 2. So if I divide both sides, so I'm trying to solve for x. If I divide both sides by root 2, I'm going to get 2 root 6 divided by root 2. Root 2 will cancel into root 6 and become root 3. And so my final answer would be x equals 2 times root 3. So I can do either one, but anyway, so that's how you find the length of one of my sides. But this becomes 2 root 3 times 2 root 3. And so that's going to be what? 4 times root 3 times root 3 is root 9, which is just 3. So the area of that square is 12 units squared. Okay. All right. So the base angles of a trapezoid are 5 and 11. And so for this problem, that's a trapezoid. So let's draw that. Okay, so we have a trapezoid. The bases are 5 and 11. But you also know that the legs are 5. Okay, that's interesting. So find the length of the median. Well, the median is this length that goes from here to here. Okay, and so we want to find the length of the median. To find the median, all you have to do is add the bases up. So that's going to be 5 plus 11 and divide by 2. So that's going to be 16 divided by 2, which is 8. Okay, and that's 8 units. The height of the trapezoid, now this is a little bit different. So we're going to have to do this, bring this straight down. That becomes perpendicular. That also comes straight down and is perpendicular. And because it's isosceles, that means that these two sections right here and here are exactly the same measure. So we can bring down the 5. This distance here is 5. And so 11 minus 5 is 6. If we divide 6 up, we're going to get a 3 here and a 3 here. And so this looks like a 3, 4, 5 triangle. And so to find the height, 3, 4, 5, we're done. Height is 4. Okay. Now, lastly, we want to find the area of a trapezoid. Now, we have two formulas for area of a trapezoid. The first one is height divided by 2 times the sum of the bases. So base 1 plus base 2. Or you can say the median times the height. Because isn't base 1 plus base 2 divided by 2 the median? So in this case, the median is 8 and the height is 4. So 8 times 4 is 32. So that's our area of a trapezoid. Okay. All right. Let's see here. Find the area of an equilateral triangle that is inscribed in a circle. An equilateral triangle that's in a circle. So let's draw the circle first. And then draw our equilateral triangle. Equilateral means all sides and all angles are equal, congruent, which means then that they're all 60 degrees. Equilateral triangle that is inscribed in a circle, the radius is 6. So I'm going to put this in here, put my radius in, and it looks like my radius can go right here. So that's 6. Bring this down. And when I did that, and when I cut this right here in half, that became a 30-degree angle here. So again, across from the 90 is 2a. So we can set that equal to 2a. So a is equal to 3. And then that's 60. So we know that this is 3. And then this is a root 3. So that's going to be 3 root 3. So find the area of the triangle. So the area of a triangle is equal to 1/2 base times height, where the base has to be perpendicular to the height. So that's going to be 1/2 my base. Now remember, this whole thing's my base, not just this part. So that's going to be 3 root 3 plus 3 root 3, which makes 6 root 3. So my base is 6 root 3 times my height. Now, remember when we were doing our construction unit, we had our medians. This is 2 to 1. So this right here, there's 2 of those. So 1, 2, 3. So this is 3, 6, 9. So that makes 9 right there. That's my height. So this is going to be, let's see, 1/2 of 6 is 3. 3 times 9 is 27 root 3 units squared. Okay. Alrighty. Let's see. Find the area of a regular hexagon that has a perimeter of 24. Hexagon. So 1, 2, 3, 4, 5, 6-sided shape. Area of a hexagon or area of any polygon is, we have 2 formulas for that. It's 1/2 ANS, or we have the area equals 1/2 A times P. For this one, it's our apothem times our perimeter. Whereas this one here is our apothem. Here is our apothem times the number of sides times the length of one side. So that's your S. Your S is your length of one side, N is the number of sides, and A is your apothem. Or apothem, depends how you say it. Okay, so for this, we know that it has a perimeter of 24. So if I have 6 sides, that means each side is 4. Okay. Draw on your apothem. Okay, there we go. And I'm going to cut this in half. Now, how many of you remember that the sum of the angles inside of a hexagon? So if you forgot, it's 180 times n minus 2, and that's going to give you the sum of all the angles inside. Okay. So if I did that, I would go 180 times 6 minus 2, which is 4. 180 times 4 is 720. So that's the sum. So I would then take 720 and divide it by 6, because then I get each angle, and that actually is 120 degrees. So there's 120 degrees. And again, if I cut that in half, that becomes 60. And again, it's a 30, 60, 90 right triangle. Opposite. Okay, so let's see here. That's 4. That's 4. That makes this 2. So A, that's going to be 4. And then my height here, my apothem, is going to be, what is that? 2 root 3. Okay. So my area is equal to 1/2 my apothem, which is 2 root 3, times my perimeter. And my perimeter is 24. Let's see. Looks like my 2's will cancel. So I'm left with 24 root 3. And then that's, units squared. That's the area of my polygon. The diagonal of a rectangle is 2 root 3. So here's the rectangle. So my diagonal being 2 root 3. So here's that, 2 root 3. The height is root 5. So there's root 5. Find the area of the rectangle. Well, area of a rectangle is just base times height. We already know that the base and the height are perpendicular. So you don't really have to say that like you would with a triangle. So let's see here. Area of our rectangle is base. Don't have that, but we do have the height. The height is root 5. So in order to find the base, I'm just going to use Pythagorean theorem. And I'm going to say x squared plus root 5 squared is equal to, parenthesis, 2 root 3 squared. So we have x squared plus root 5 times root 5, which is just 5. Let's rewrite that. And 2 root 3 times 2 root 3. Remember, numbers get multiplied with numbers. So that's 2 times 2, which is 4. And then root 3 times root 3, which is 3. So we have 4 times 3, which is just 12. So x squared is equal to 7. So x equals the square root of 7. So my length here is going to be the square root of 7. So in order to find the area, we're going to go base times height. So my base is root 7. So we're going to go root 7 times root 5. And the rule is to keep the base, but to multiply the numbers inside. So it's just root 35. And then that's units squared. And that's the area of the rectangle. The lengths of the diagonals of a rhombus are 10 and 24. So some pretty cool things about a rhombus. Number one, the diagonals are perpendicular. So that makes them, that's pretty neat. Also, it has 4 sides congruent, okay? Find the lengths, find the perimeter and area. So the perimeter is just the sum all the way around. Area is area of a rhombus, which I draw like this with the perpendicular lengths, the diagonals there, is 1/2 diagonal 1 times diagonal 2. So the diagonals are 10 and 24. We already know those. So we just say 1/2 10 times 24. And that's going to be 2 goes into 10, 5 times? 240. Actually, I'm going to go 2 into 2. Doesn't matter. 2 into 2 times 5 times 24. So that's 24 times 5. So that's 5 times 4 is 20. 10, 11, 12. That's 120 units squared is my area of my rhombus. So that's my area. But once I have that, I need to still find the perimeter. Okay, and so that's a little bit more trickier, because in order to find the outside lengths, I need to use the diagonals that they gave me. So if the diagonals are 10 and 24, so that would make this 5 and 5 because the diagonals are bisected. That would make 24, 12, and 12. And it looks like that's a 5, 12, 13 triangle. If you recall from your triplets, let's see what those were. The Pythagorean triplets are 3, 4, 5, 5, 12, 13, 7, 24, 25. And there was another one. What is it? 8, 15, 17. That's right. Okay, so the perimeter, getting back to the question, is 13, 13, 13, and 13. So you can just say 13 times 4 is my perimeter. That's 12. 4 and 1 is 5. So our perimeter is equal to 52 units, not units squared, because we're not multiplying lengths. We're just adding up lengths. So that stays at just units. Okay, find the area of a circle. So we want the area of a circle. The circumference is 30. Well, the distance around. So I can say circumference equals 2 pi r. If I know that it's 30 pi, so we can say 30 pi is equal to 2 pi r. I'm going to divide by pi on both sides, and those are going to cancel. And then I'm going to divide by 2 on both sides. And so my radius is 15. Now, that's not the answer to the problem. I still need to find the area. But what that does is it gives me my radius. So then I can say area equals pi r squared. So pi times 15 times 15, which makes 225 pi units squared. So that's my area. Draw a trapezoid where A, B, C, D, let's see here. The area of a trapezoid, this is what, number 10. So the area of the trapezoid is 84. You know, AB is 17. So for this problem right here, you got to be careful how you draw that, because I think this is sort of a trick question. What we know is that this looks like this. Okay, but A is not up on top. Normally we just say A, B, C, D like that, but I believe A is here, B, and then C and D. And the reason why I see that is because it looks like the AB is longer than CD. So this right here is going to be AB 17 and CD is 11. Okay, so that makes sense that that's smaller. I need to find the height. Let's see. Oh, but I do know that the area is 84. So for my formula, let's see, area equals height divided by 2 times the sum of the bases. So I'm going to say 84 is equal to the height divided by 2 times 11 plus 17. What is that, 28? Half of 28 is 14. And so then I have, let's see, move that up here. So I have 84 is equal to 14 times my height. Height then is equal to 6. Divide that out. Okay, so it's H units. Then I have to draw it again. Oh, and by the way, we know these are parallel, so that's, forgot to put those in. So again, I'm going to redraw my trapezoid. And I know that, let's see, here's A, here's B, and then C, and then D. And AB, let's see, AB is 15, so that's length is 15. DC is 10, no, DC is 8. BC is 10. And angle B is 30. So that's interesting. So what that does is do this. All right. And so what it looks like to me is if the area, find the area. Area is equal to height divided by 2 times the sum of the bases. And so my area is going to equal my height, which I don't have yet, which I can get actually because this is a right triangle. And across from the 30 is A. Across from the 90 is 2A, which means across from the 30 is going to be 5. So that's actually going to be 5 divided by 2 times the sum of the bases. Now my bases are 8 plus 15. Ooh, so what is that? 23 times 5. I think that's 115 over 2 units squared. Okay. And lastly, we have C. C says if AB is 13, so we have this again. So here's AB, C, D. It says AB is 13. We have a height of 5, okay? And we know the area is 65. We need to find the length of CD. Okay, so area, which is 65, is equal to height divided by 2 times the sum of the bases, x plus 13. So what I probably would do is just multiply 2 times 65, and then to get rid of this 2, and then let's see, then I would just multiply through by 5 and minus 13. I think that's 13. Actually, this is interesting. X equals 13. This quite possibly is a rectangle now because I did get x equals 13. Okay. Lastly, find the area of a trapezoid. Find the area of the trapezoid. So what we do know is that this is 10, this bottom length here, and that would make this 45 if that was 90. And that would be a 45, 45, 90. And this would be a 60. And so, oh, I didn't realize that. Anyway, so we would go height divided by 2. So height divided by 2 times the sum of the bases. My height should be the same, but I don't know that value. But I do know that that's 10, which means this is 6. So that's 6 divided by 2 times the sum of the bases. So all I need is this base right here. So these are both 6. 6 root 2. And if that's 6, that's opposite the 60. I can say 6 is equal to a root 3. And then I can divide by root 3. And so that makes 6 divided by root 3. But you're not going to leave a root on the denominator. So you're going to multiply by root 3 over root 3. So you have 6 root 3 over 3, which becomes 2 root 3. So it looks to me like we have 6 divided by 2, which is 3. So the area is going to be 3 times 10 plus 2 root 3, which becomes 30 plus 6 root 3. And that's units squared. So that's the area of my trapezoid. Kind of fun. That was interesting. So that's it for part 1. And look for the second part of the review momentarily.